Viscosity. So why viscosity you should read? Because viscosity means resistance to flow and inverse of viscosity fluidity. So if certain fluid is having very high viscosity, so fluid will not be flowing easily. For example, if you have grease and if you are giving grease on some floor, it will not move actually, very semi solid grease. Sometime liquid, let's say oil, cooking oil, it will be flowing but not so easily. But if you have, let's say, aniline or the very light oil, petrol, they will be flowing very easily, quickly, right? So some fluid will be moving on flows flat surface very quickly, some will not be moving at all. So if you are moving quickly, so that means their viscosity lower. If it is not moving, that means viscosity very high. Toothpaste, grease, their viscosity very high. But if you see oil, viscosity lower, diesel will be higher, lubricating will be higher, diesel will be then will be petrol, right? And if you have water, water viscosity 1, okay, and oil, when we are talking about oil, oil viscosity a little bit higher than water. So whenever you are lubricating your machine element, you will be using long chain hydrocarbons, not fuel oil like petrol or diesel, because it will be at high temperature, it can burn. So normally lubricating oil will be used, right? So viscosity means it will be resisting flow, but it will have several layers sliding over each other. Okay. Now why should we study viscosity for artificial lifting system? So if you have very high viscosity, fluid is not flowing, you need mechanical arrangements, say ESP system, sucker rod pump, and fluid is not flowing. So your sucker rod pump, although it is working, but it will be requiring very high amount of force. Okay, high electrical energy consumption will be there. Some pumps will be there, for example, ESP, electric submersible pump, they will not work if you have very high viscosity, but some pump will be very efficient if you have very high viscosity. So you should know viscosity of fluid. Based on that, actually you have to select your pump, your artificial lifting mechanism. Okay, so first you have to know how to measure viscosity. So there may be several other methods available, but one method is the rolling ball viscometer. Rolling ball viscometer is like this: take one slant surface, okay, fill with some viscous liquid, okay, fill with viscous liquid, and a ball, okay, put a ball here. This is one ball, okay, and if ball is starting rolling from here, so what will happen? If very high viscosity is there, ball will not move, right? It will not move, it will not roll. But if you have very thin fluid like water, slowly it will moving down, right? It will do like this. But if you have very thick fluid, let's say grease or toothpaste you have taken and you put one ball, so what will do? The ball will not move at all. So because viscosity very high. So in this way, you can measure how much viscosity is there in the fluid. And one formula is there in this rolling ball formula, L1 rho 1 may be fluid viscosity, fluid density, not viscosity. This is ball density. G you know already, acceleration due to gravity. R is the radius of the ball, radius of the ball, and theta is the included angle, and V infinity is the settling velocity. Ball velocity, settling velocity, okay, and eta is the viscosity. Now, what are the forces acting? So when it is moving down, viscous force will be trying to move it up. Gravity force is going down, it's moving down, working downward, right? And the gravity force, this one, buoyancy force will be there. Okay, buoyancy force, it will try to move up, and viscous force, it will resist, it will say, hey, don't go. And gravity force, it will try to pull down. So gravity and buoyancy force both will be working opposite direction, right? And but still ball will be trying to move because of this component of gravity force. Now, if you have low viscosity, so it will be moving quickly. If it has very high viscosity, it will be moving fast. So in the so let's say from this distance to this is how much time it is taking, and distance divided by time. So you can calculate velocity because distance divided by time, right? So how much distance is travel and how much time. So if you get that velocity, so from that velocity you can calculate viscosity. Now you can take any fluid, let's say reservoir fluid or fluid on the surface, and you play with this ball and you can get viscosity amount, right? So this viscosity, when you measure, this will be used by your artificial lifting people, it will be used for surface production people, because it is resistance to flow. Viscosity meaning is the resistance to flow, and opposite of viscosity is the fluidity, how much quickly it can flow. And if you know resistance of flow, accordingly you have to design your pipeline system, you have to select your choke, you have to select your surface separation systems, you have to select your artificial lifting system, your valve mechanism. All the things will be based on viscosity actually. Okay. Next. So viscosity, there are several correlations available. So one correlation is that Ahmed correlation. So dead oil viscosity is given here, mu OD. Dead oil viscosity, D means dead, O means oil. Dead oil viscosity 0.32, 1.8 to 10 power 7 API, already defined, 4.53 API power 0.553, 360 T again degree Fahrenheit. A is one constant will come from here. Constant is A is here. So 10 in power 0.43 plus 8.33 API. So sometime I give assignment and I ask the student, okay, using this formula try to calculate. Maybe some term will be unknown, some term will be known, and you have to understand how to solve it. Okay. And here some terms are there, I have to explain. RS solution gas oil ratio, and P pressure, PB bubble point pressure. P is pressure, PSIA, PB bubble point pressure. Mu OB saturated oil viscosity. So why saturated oil viscosity? That when bubbling will start, so that at that point what will be the viscosity, the formula is here. Okay, this is dead oil viscosity. And unsaturated oil, when temperature pressure is such a way managed such a way that it is above bubble point pressure, that it is unsaturated. That means it needs more oil or more gas to be saturated. Yeah, so saturated unsaturated definition is like this. You take certain amount of oil and gas mixture at certain pressure temperature, and you reduce pressure. Say once you reduce pressure, bubbling will start. At the moment bubble starts, you assume this gas is actually, this liquid is saturated. Okay, and this is bubble point at bubble point. But at the same temperature and pressure, if it can absorb more gas, then it is unsaturated. But if certain fluid you are having and free gas also there above it, okay, so that means it is already saturated because extra gas is there still. Again, the equation is very big, so remembering will be difficult. So what will I do in the exam? I'll give some correlations and I'll keep something missing. So if you do not practice, then you will have difficulty. So better you practice based on this one, this formula, the given problem, then you can solve. Yeah, there is one correlation of oil viscosity, viscosity, pressure, and viscosity on mu. It becomes like this. So okay, if you reduce pressure up to bubble point pressure, viscosity normally it will go down. Then again, when gas will be released, then again viscosity will go up. And at dead oil condition, dead oil will have higher viscosity. But when you take a fluid above bubble point condition, so that time when you release pressure, actually viscosity will go down, okay, because the molecule will get more space and it will create less resistance to flow. So, viscosity will go down, then bubbling will start. So, when free gas is moving out from the liquid, so that time viscosity will go up, 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 and it will reach maximum when it will go to the dead oil condition. Dead oil condition means surface condition 14.7 psi, 60 degree Fahrenheit. We will go to next topic. Next topic is oil compressibility. Oil compressibility, you take certain amount of fluid mixture from reservoir, take to surface. Because of pressure change, the fluid volume will change. Okay, if you see the formula, it is compressibility formula. Unit will be psi inverse. Okay, pressure inverse, because here you see this del V is there and at bottom del P is there. So, because of this reason, it will be inverse of pressure and it will be at constant temperature. It will be in isothermal condition. And why the compressibility changes? Because at high pressure, the atoms will be compacted and it will coming closer to each other. When you release pressure, so atom will be getting more space. It will be getting more resonance space. So it will take more volume. So that is called compressibility. So compressibility, if we draw the picture, is like this. P and it's like this, almost constant, and this is psi inverse, and this is PB, the bubble point pressure. So when you reduce pressure, compressibility will go down. Once it reaches bubble point pressure, again compressibility will be going up because lots of gas will be released. The free gas is released, so compressibility is getting up and up and up. So when dead oil is there, so it will have maximum compressibility. Okay, now gas, specific gravity of gas. The specific gravity of gas, when I am talking about, then we have to know, when I talk about specific gravity of gas, we have to know the molecular weight of a gas or apparent molecular weight. This is called apparent molecular weight. Apparent molecular weight, and 28.97 actually air atomic air molecular weight. So if you have gas, natural gas or gas coming out from wellbore, it will have multiple components. So multi components is not single component fluid. That means you have to see how much percentage of component, which component is there. So for that we have that equation, apparent molecular weight equals NC number of component and Yi fraction of the molecule MWI. So apparent molecular of each molecule molecular weight you have to find, then you have to calculate apparent molecular weight MWA. And this is available, this formula is available in IMAT 1989. Gas viscosity. So oil is having its viscosity, oil will try to flow, but because of viscosity it will get resistance. So gas also will get resistance, but gas viscosity, gas is a lighter molecule, so its viscosity is not so much prominent as liquid viscosity. And gas viscosity, if you see, it is 0.01 to 0.03. So very low viscosity is there. So but still you have to know the viscosity formula, because whenever you are designing a system, the small change in viscosity also will affect the whole system performance. So gas viscosity, one formula is there, kinematic viscosity Vg equals mu g by rho g, and you have to note down the units also. If you do something wrong in a unit, then there will be a problem. Okay, so gas viscosity is this one. The poise or centipoise is the basic unit. 1 centipoise is water. And if you are saying kinematic viscosity, that is centi-stoke. So normally the kinematic viscosity term is not used, only dynamic viscosity. This is called dynamic viscosity. dynamic viscosity. Dynamic viscosity is used for all calculations in the oil and gas industry. But you should know how to calculate. If kinematic viscosity is given, then dynamic viscosity you have to calculate, and you have to know this mu g divided by rho g. Mu g means gas viscosity by rho density. Gas density and a gas viscosity. Viscosity. And if you have multiple component, then you have to use this formula: gas viscosity of component 1 percentage molecular weight divided by percentage molecular weight square root. So this formula will be holding. And if you see common relationship in graphical plot, so it will be like this: viscosity. So in general, viscosity means dynamic viscosity, mu. Viscosity mu, and this is psi, pressure. So viscosity normally it will be like this. If you increase pressure, viscosity will increase. Why? Gas molecule are separated, right? It is not closed like liquid. So if you increase pressure, so gas molecule will be coming closer and it will have more collision. Okay, because of Brownian motion, the gas molecule will have collision, lots of collision, randomly moving here and there, lots of collision. When collision increasing, actually it will increase viscosity. Okay, so when you are increasing temperature also, again you will have higher viscosity. So why? Because increasing temperature means you are giving more energy to the particle, so particle will be moving much faster. Much faster means much faster collision, viscosity will increase. Again, pressure also increasing, your viscosity will increase. So viscosity is a function of basically pressure or temperature. Okay, compressive factor of gas. So ideal gas compressive factor Z is 1. But if you are saying about natural gas or other gases, normally compressive factor Z will be less than 1. So Z V actual divided V ideal gas is the ratio. Okay, the term use compressive factor, Z factor or deviation factor. So deviating from how much? From ideal gas. The ideal gas means everything is perfect and Z is 1, but in practical Z is not 1. And the formula from PVRT, so PV equals Z N RT, N is number of molecule, and you have to see again units. If you do not convert unit properly, your things will go wrong. So if you have pressure psi, volume cubic feet, and per mole degree T Rankine temperature if you take, then R value will be 10.73. If you change unit, then again your R value will change. So you must remember, if it is R is dependent on units. So randomly if you Google search and if you take R value and you try to calculate, then they will be wrong. So first you have to see which unit they are using. Based on that, your calculation result will come up. Next is density. Again, density means particle far apart from each other because it is gas. Now you increase pressure. When you increasing pressure, it is coming closer. So when it is coming closer, density increasing, viscosity increasing. So temperature, pressure both will affect. The high pressure, your density will increase. If you okay, same volume, pressure increasing, density will increase. Right. Now, what is the formula? Rho g gas density is m by v. Simple formula. mw apparent molecular weight, p is psi, z compressive factor, r already you know, T is Rankine temperature, R is universal gas constant. And if you are assuming air molecular weight 29, then rho g will come like 2.7 gamma g rho, gamma g p, z t. Gas formation volume factor. So gas, when you are taking from well bore and you are taking to surface, for reservoir to surface, so its formation volume factor also will change. but we are assuming this is gas. Gas means during reservoir condition also it is gas and surface condition also gas. And how the volume is going to change? It is like this. This is single phase gas. So psi and gas F V F formation volume factor, and for dry gas. Okay, so if I give any problem formation volume factor, then you have to check whether it is for oil I have given or I have given for gas. So you have to know how much compressibility will be there, and due to pressure change and temperature change. So here also same compressive factor definition as same as oil, Cg inverse of pressure 1 by V minus 1 by V del P by del P. So because of pressure, volume is going down. That's why the negative sign will be there, and this is again isothermal compressibility. Why these are required for artificial lifts. Okay, you got certain amount of fluid, and when fluid is moving up to the surface, is changing phase, is changing volume, is changing density, is changing viscosity. And let's say you are designing one PCP, progressive cavity pump, and you have lots of gas. Initially you thought single phase liquid PCP you will use and things will be okay, but because of phase change, phase diagram if you draw that, because pressure and temperature change, there will be phase change. Because phase change, you got some gas, and if gas is interfering PCP, then PCP will fail. So your PCP or progressive cavity pump is failing. That means your production will be hampered, and you will be spending more money than producing your oil or gas. Okay, or you are having sucker rod pump. Sucker pump, maybe it is working well, very nice initial stage, but later stage you found that it is having lots of gas or viscosity changing. Because of changing viscosity, maybe more water came into wellbore, or more sand came up. Because of that, your fluid property changed. Because of fluid property change, fluid will not get lifted up, or maybe sucker rod pump will get blocked. ESP system, it may not like lots of high viscosity, and if you are giving very high viscosity because of certain reason, you got more viscosity or viscosity change. You initially viscosity was maybe 20 API, later it changed to 30 API. Again, same artificial lift may not work. So you have to know fluid wellbore properties, fluid properties, then you have to select or design your artificial lift. Then you can enhance your production. If you do not consider this basic part like fluid properties, reservoir properties, how to handle the surface fluid, then what will happen? You select certain artificial lift, it will work for maybe 6 months. After that, maybe your productivity will change, your fluid property will change. Again, you have to change the whole artificial lifting system. So when you are changing, it is very expensive affair. For example, if it is inaccessible wellbore, for example in desert area or in forest or in horizontal wellbore, so workover or intervention operation is very much expensive sometimes. So you have to put one artificial lifting system or pumping system such a way that it will run for longer period without intervention or workover. Whenever you are going for workover or intervention, your expenses will go up. You have to stop fluid production, you have to rework in the wellbore, you have to put again artificial lifting system again. So that will be very much expensive affair. So before you select or design any artificial lift, you have to know the fluid property, reservoir property, how to produce wellbore, how to separate on surface also. That also required actually. So whole gamut of understanding required before you select or design any artificial lift. So thank you very much for today's lecture. Again tomorrow will come with new topic.